You guys don't do table of contents. 1.4, page number. Whatever page is nice and clean and not written on. Pass the one that you wrote on yesterday. You writing on the nice clean one? That's good. Section 1.4, functions. Whatever page number you have should be in the front. What do you think as the year goes on and you get tired and there's a lot of stuff going on, you start to get stressed? A test comes and I say, hey, turn in your notes, what happens? My table of contents. So what am I trying to teach you? Just keep it updated along the way and then you never have to do the whole frantically trying to update your table of contents right before a test when you should be thinking of other things. Calmly, confidently. Maybe a little bit purple, but Happy Friday. Happy Friday, kiddos. You like Fridays, yeah? Is this a bad Friday? Lots of quizzes or tests? Yeah. Going out to support football this week? Tonight or tomorrow?
Tonight.
It's gonna get so
gnarly. What?
It's gonna get gnarly. Why is no one else excited?
I didn't hear what he said first.
So that's how it works. I read the Bible and had a lot. I didn't make it in the yearbook last year. I didn't. I went to Atalanta before any of the others did. So,
We need a drum line this year. That's the real question.
I don't think we're ever gonna get that. Honestly.
It makes all the difference.
Okay, that out of
Just gotta get Issa on it. Not you, Issa. Other Issa. He is on it? Oh no.
It's good.
Hey, we're recording. Okay, section 1.4, functions. Here we go. Okay, relation. Any set of ordered pairs relating to quantities. Uh-oh, as soon as you hear relating to quantities, yes, it could be y and x, but it could also be word problems. It's okay. We're strong. We're independent. We can do this. Function. A relation where each x is paired with one and only one y. Do you remember what test it has to pass?
The vertical line.
The vertical line test. Some of you might not have heard of that before, but a lot of you have. Vertical line test. How can we quickly make a vertical line? Yeah, at least we symbolize it. Why is this not truly a vertical line? Because a line has no depth. Interesting. Can't really ever show you that, because if you can feel it, there's depth. But anyway, a sliver of paper might come close, or a string might come even closer, but even then, it's not a line. But either way, you can pretend like your pencil is a line, right? And as you run it across a function, if it hits more than once at any one point, yeah, it fails. Let's keep going. Uh-oh. One's a graph that's not connected, and one's a table. Struggle. That's not normal. Let's get back to letter A in a second. Government people help me out. But Let's work backwards. I want you guys to think about C, then B, then A, and let's just talk it out as a class, huh? Letter C, it's the scatter plot. Is it a function? Yes or no?
Yes.
Yes. So if you take a vertical line, first of all, no points, no points, no points, 1 point. Any more on that line? Nope. Keep going. 1 point, we're good. 1 point, we're good. 1 point, we're good. 1 point, we're good. Each individual x value only has 1 point on its vertical, remember vertical tick mark? Vertical line. You can think line of sight sort of. So letter C, yep, he's a function. Letter B, check him out.
It is.
A function? Maybe.
No.
Oh, You're just reading.
No, it has the,
Excuse me.
you gotta consider the X table.
Yeah. You have to look on the x side, not the y side. And we have, if we were to graph it, our problem comes right here, x equals 2, which maps to both 10 and 11. Doesn't work. We can't have one input getting out 2 different outputs. It doesn't make sense mathematically. Not in a normal equation. So hence, because of this, nope. Not a function. Now what can we call it? It is a relation. Oh my. It is a relation. Ooh, I have one on my desk. I was just waiting for him to come out.
Good question. I don't know what she means by that.
Okay. You circled those two because there's 2 x's of like the same one.
Same x, different y's.
So that makes it a relation instead of a function.
Yes. And technically, this one over here, guys, remember, a function is just a special type of relation. Like, for instance, a dog is a special type of mammal. Same thing. So a dog is a mammal? Yes, a dog is a dog. A cat is a dog? No. But a cat is a mammal. Same thing here. Does that make sense? Working on it. All right, so letter A. Letter A. Input. If we were to make a graph, number of and I got lazy. Tips. There we go. Number of representatives from a state. Output is the number of senators. That's a bit more creative than we're used to. Number of representatives versus number of senators. All right, people in government, how does that work?
I mean, the number of senators is
They're
always
independent.
2.
It's always 2.
So it's gonna.
Number of representatives
It's a function.
changes. But why is it a function?
Because we want it
Is it possible to have any more senators than 2?
No.
So what kind of line is it going to be? Right? No, not that there's an infinite number of representatives from a state, but based on number of representatives, they're all going to be 2, 2, 2, 2, 2, 2, 2. You can't have more than 2 senators, so therefore we can say, yes, that's a function as well. I just want to try to be all applicable to other subject areas. Okay, so let's keep going though. And you guys are used to the whole, hey, a circle is not a function, right? You're used to that one. So I could give you that one and you're like, is it a function? No, it's a relation, but not a function. Like, that's normal. That gets too easy after a while. But something we do have to be careful of is, what does that equation look like? Why is it x squared plus y squared? Centered roughly at 0. We'll just do like a 1 and a 2 and a 3-ish. There we go. Equals 9. How could I tell with the equation? That gets a little harder. Does anybody know how we can tell from the equation that it's not a function? Kind of.
Oh, because you're gonna have to use x. You're gonna have to use the square root to a negative x squared.
If you try to get y by itself, how many different pieces are there when you solve? 2 of them. There are 2 functions in the one equation. 2 functions? That's not good. Okay, anyway, keep going. This stuff is theoretically easy cheesy. It's technically the rule of 4. That's what a lot of math teachers would call it. AP calculus teachers would too, the big rule of 4. 4 different ways of dealing with math specifically. And to be honest, it kind of blends over into any field that uses math, like chemistry or physics or economics. There are different ways of representing different ideas, but specifically with functions, there are 4 different ways to represent. Let me just give you a second. You don't really need to skip any space. Skip one line. Skip one line. That'd be nice.
So.
Okay, verbally. Example number 2 isn't necessarily a literal thing to do, it's more just a quick idea. But verbally, if we're dealing with math, what are we dealing with?
Word.
Yes, right? Words, a paragraph, a sentence, a situation, a scenario being described to us. Numerically, what are we dealing with?
Numbers.
I'm going to say data points. You're right, numbers, but data points, and usually found in a table. What are you doing when you're making a table with all these different sorts of data points or all these different sorts of data? You're doing a science lab, right? A lot of those labs, you have to collect data and then you try to think about regressions and those sorts of things. Anyway, numerically, usually it's experimental. Graphically, that one's easy. And algebraically, we're dealing with functions or we're dealing with equations because not everything is a function as we notice. We're actually looking at the equations themselves. Kind of like a second ago, I drew the graph of the circle and I was like, that's one way of thinking about it and that's easy for our brains. But what if we have the equation instead? Could we match it with the graph and then make our analysis? So example number 2, just checking it out real fast, we should be able to quickly label and say, oh, hey, this one is, of course, dealing with math verbally. This one is, of course, dealing, looks like I'm labeling this, dealing numerically. So we have just data points. And this one is, of course, graphically. Once again, not something necessarily you have to spend time writing. Just a quick understanding. What would you like for writing? A couple more seconds. Verbally, numerically, graphically, algebraically. And with numerically, you guys are used to, just a quick heads up, you guys are used to tables that are vertically oriented, right? But we're going to try and get you to tables that are more horizontally oriented. They're a bit more applicable. Just a little random heads up. If you like graphs better than equations, that's good, but we have to get you good at equations. If you like equations better than graphs, that's good, but we got to get you good at graphs. We have to give you or let you or help you become more fully rounded. Sound good? All right. Uh-oh. As soon as you see this word in math, what are we thinking? Oh, stink. Okay, you might be thinking graphs. That's true. Translations is a thing. Transformations, dilations, stretches, reflections, okay. But take a step back from that for just a second and just think English. Translating words into algebra. Stink. Getting you ready for word problems. Don't worry. I have full confidence. We'll be okay. We'll still be breathing by the end. Hopefully we've gotten some sleep.
I'll be like 100% honest. In the homework problems last year, Mr. Crawford's, that were word problems, I would be pretty much like, nah.
I know, right? I think that's human nature, Luca. To look at it and be like, not feeling that one, but why? Our brain likes dealing with math in a mathematical way, not a verbal way. So graphs or equations. Some people hate graphs, and so they did the same thing with that too. Some people hate tables. But the point of math is that it can be applied, and if we never work with applying it, then we're kind of learning a pointless subject. I don't want to waste your time. I know you don't want to waste mine. Hopefully. So we have to apply it every now and then. And ultimately, to be honest, we're kind of just building you up to be able to apply it much, 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 much further in calculus and beyond. But not every field, not every job is going to require calculus, to be honest. A lot of them do, a lot don't. A lot of it happens behind the scenes or in a computer program that someone developed and you're just using. But all fields, all jobs do require some sort of interpretation of data, of information, of communication, some sort of taking information and processing it in a correct way. That's what we're going to work on. So when you see something like y is a function of x, or y is a function in terms of x, if you ever took Mrs. Leon, this hopefully won't be too bad. Question. Who's independent and who's dependent?
Independent is X, dependent is Y.
And that's also known as the input. College professors would like me to say that, so I'm saying it. Dependent variable would be Y. In this context, which is the output, but just a few of you, as soon as we step back from Y's and X's, you just get lost. So let's try to go ahead and make it a bit clearer. When we see something verbally like is a function of or is dependent on, whatever comes first in that phrase is quite literally the dependent variable, otherwise known as the output. But when we see something like who is it in terms of, who is it a function of, who is it dependent on, what if there wasn't an X? What if there was a word there? Could you figure out that that is indeed the independent? To label it. In physics, it's almost never X. It's almost always time. T is the independent. And you have like velocity in terms of time and position in terms of time and acceleration in terms of time, all sorts of stuff in terms of time. So we have to make sure that we can figure out who is the independent, who is the dependent, before we can even ever start figuring out an equation. Huh.
Just like thinking ahead, I can think of word problems verbally, numerically, and algebraically, but how would it be a graphical word problem? Because you need a function, and you need an algebraic function to make a graph.
Okay. Let me give you an example, just real quick though. If the word problem stated something like a constant rate. For instance, imagine you're driving, cruise control is as close to constant rate as we can come in a car, because you're staying at one speed. How is, at a constant rate, how is your position changing?
That's numerically also, you can put in.
I mean, you could plug in, right? You could say, okay, after 2 seconds, I'm going 60. After 3 seconds, I'm going 60. After 4 seconds, I'm going 60. That's true. But if you're trying to think about your actual movement, constant rate is constant slope. Constant slope is a linear function. So you're always changing distance at the exact same intervals, that same speed. Does that make sense? So it could be something like constant rate, where they're not telling you specifics, but you have to pull out from that, ooh, it's a line, and then we can use different techniques with lines than we could do for like quadratics. Just a little one. But you're right, usually graphically comes out of algebraically or algebraically comes out of graphically. But if you think about scatter plots, which would be numerically first, right, collecting all this data, scatter plots, and then seeing if there was like a general trend upward, that's statistics. A general trend, then you're looking at the graph of the scatter plot and saying, what's going on? With all this data, I can't see it. Most people can't look at data and see, but if you graph it, you're like, oh, okay, I see. It's an upward trend. That's kind of what's going on. Words. Words, words, words. Words, words, words. I'm dying. Words. Now, hold on, quick example. Remember how I said in homework number 2 and 3 you were supposed to start summarizing directions and problems? But I did say that there's an exception when it comes to what? Okay, so let's think through this. If I wanted you to write something, but you didn't have to write everything, how could you summarize this problem? Let's see. Let's move B down and A down. If I was to summarize this problem, I would call it the soft drink problem, right? Soft drinks. Can you narrow those and taller? Not really. Soft drinks can. Let's do that. Ratio of height to radius is 4. Why am I showing you this? Because you don't want to write the whole paragraph in your notes, but you can write soft drink can ratio of height to radius is 4. Yes, they tell you the purpose. They're trying to make it narrower and taller to make it stand out, maybe like the 7-Eleven, like, I don't know, refrigeration section, whatever. Why is it taller and narrower? I have no idea. Why is it shorter and fatter? Maybe they can fit more. Anyway, whatever. They're trying to make it slightly narrower and taller. But that doesn't really apply necessarily. The important stuff is you're working with a soft drink can or soft drinks can. Maybe I should do singular. Apologies, my grammar. A. Volume. Function, FN, great. Function of radius. B, we switch things around and we say, hey, let's make volume as a function of height.
I'm sorry. What do you mean?
No, I know, don't worry, it's coming. Right now I'm just writing the question, okay? Now hold on. There's a huge clue that I haven't written but is implied just in the nature of the problem. I wrote down height to radius is ratio of 4. I wrote down what we want, volume in terms of just R, volume in terms of just H, but what am I leaving out even though it's implied in the problem? A can is a cylinder. Cylinder, that's geometric. Geometric, I have a formula for volume. I know what this volume formula is. Volume equals
Circumference times the height. 2 times circumference times the height.
Ooh, you're thinking surface area. Volume is the inside. It's area of the base. Pi r squared times the height. I need the inside. You were thinking the outside. Now, some of you are like, I wouldn't have gotten that. Sweet, good thing we have Google. Okay, so Siri knows her volumes. Anyway, it's okay. This pulls on the past, but the past is not always remembered. Hence why you should be doing it. Anyway, pi r squared h. What's the problem? What's volume right now? As written, a function of pi. Nope, pi is a number. What's volume a function of right now? R and h. So how do I make it only in terms of R and then only in terms of h? Ah, steep. I have to get rid of h and get rid of R and put in. Well, how do I get rid of it? I must need to substitute something. So there's information somewhere that I can plug in, but what is it?
Use that ratio.
Use that ratio. What's ratio mean in math?
Like a proportion and
A proportion, it's a fraction, right? There's a fraction. So hold on. Ratio of height to radius.
Even though it's not a measurement,
Even though it's not a measurement.
because so you're just considering that the top of the can is 1, the radius.
Kind of. I'm just considering for all different radii. So if radius is 1, height is going to be 4. If radius is 2, height is going to be 8. Just like the comparison. They like this shape, but whatever radius they want it similar, proportional. Kristen.
It's H or R because it says height to radius.
Good.
Okay.
So like when you were writing a long time ago with rates, You could do H colon R. You could do H over R. You could do H with a little 2 in R. It's practically one. So it's one of those things that just escapes our memory. But yeah, H2R is 4. So how do I use this? Later on in math, I'll call it my clue, my clues. Anyway, but here's the extra piece of information that was hiding, right? I babysat too much during that time. Anyway, so how do I get rid of? I need it of R. How do I get rid of H?
Put a 4 instead of
From
I need to get rid of H. So rearrange. What does H equal? 4 times. Then I plug it in. Now you guys do the next one. Use this, rearrange however you need to get rid of the R this time and end up with the H's. That looks too scary. Look at that one. What's that equal? You guys see how I got R? The first one's too hard. But the second one, once you move the R up, then you can divide by 4. R equals H over 4, plug it in the function. H squared over 16, I made it pretty. Pull the 1 over 16 out. IH cubed is there. Now, what am I trying to make a point of? That all the homework problems are just as abstract and kind of out there? No. No, they're not. But sometimes the key to the problem is being able to read and translate the information you've been given. Does that kind of make sense? You're good at the problem itself, but the need for translation. Now, hold on, pause and look. Uh-oh. We gotta do some domains and ranges, okay? There's more to section 1.4. There's actually a lot to section 1.4. However, we did work with translating today. Back here on the board, oh, I totally didn't update today. We went over section 1.3. We started section 1.4. So what's our agenda for Monday? I should say that. Finish. So when's homework due? Tuesday. Hold on. What technically was due today, but I forgot to remind you yesterday, so I'm giving you one more day. Google Classroom. Let's look at it. We have another minute, right? Homework isn't due till Tuesday. Should you start this weekend? I would. Kind of a longer one. But we have much more to go over, so don't stress if you get stuck pretty early on. Favorite online tutor is on your or in your Google Classroom. Are you guys already supposed to join? Real quick, in your Google Classroom, let me switch real quick to a student view. Try and pretend like I'm in AP Calculus. It looks very similar for you guys. If you go into your Google Classroom, pretend it's yours. You're going to see an assignment just like this. Where are you supposed to go to find the places to look at the different tutors? Website, helpful links, always spell it out. Where do you write down your response? Click on the form and type. Now hold on, how do you show me that it's done? You have to open, and then you have to go down and say mark as done. That's by midnight on Monday. Bye. Happy nutrition, I'll see you guys later. If you have any questions, I'm here. Don't forget anything.